Hey, scholars. Let's talk about the theory of constraints. This will be the last of the yellow shirt videos here, at least for today. Theory of constraints is in this book here, book 2. This is available on Amazon if anybody's watching this that's not familiar with the textbook from the class. But the starts on page 101. So first, what is a constraint? Constraint's anything that's going to cause your operation to operate at less than efficiency, and or it's going to be a part of your system that is the weakest. So change no stronger than its weakest link. What is the weakest link in the system? Constraint can also be something that's not in the system that should be in the system. I give an example in my text about a company I worked with, and their constraint was that they didn't have a CRM. They tried to figure stuff out without the proper technology, it's proper software. And so constraints can either be things that you have or things that you don't have or things that you're not using properly. There's a lot of different ways you can have a constraint, but the theory of constraints basically says that the chain is no stronger than its weakest link, and part of the operation manager's job is to identify what those constraints are and to hopefully overcome them before they become major issues in your process. There's a number of examples that I give in the text of constraints that cause catastrophic issues, but before we get into that, let's talk about the things that I think operation managers can do to figure out what their constraints are before they reach up and cause major issues in the operation. So this is for an operation that has at least some amount of maturity. So the first one is to test, measure, and observe, and that's what most of us would do most of the time. Is we'd say, okay, so what are the issues in my system? Is it people? Is it machinery? Is it is it the environment? Is it, I don't know what it is. Is it the building that we're in? But you're going to look at what how the operation runs. You're going to think about how do we do things again, better, faster, cheaper, lower cost, higher quality. Improve responsiveness, and then we're going to say, okay, well, I think my major issue is this. My major issue is I don't have enough people. Okay, well, that's a constraint. What are you going to do about it? More overtime, hire more people, train them, get better productivity. I don't know, but you're going to figure it out. That's your job as an operations manager. So you got everything running pretty good, but you're not sure how good. Another way to spot a constraint is to just push your system, test it out a little bit more. So if you, typical day, you're going to produce 100 widgets. Say, all right, guys, here's what we're going to do today. We're going to turn up the volume, and we're going to produce 150 widgets. And you just keep going until you find out where the problems are. Of course, you make sure you've got the inventory and whatnot to turn it up to 150 units. But that may be your constraint. Your supply chain may be your constraint. I don't know. But you may not know it until you push the volume up. Now, why in the heck would you do that? You might say, Bill, that's kind of stupid. But it's really not if you think about it, because 2 weeks from today, a month from today, somebody might say, hey, you know what? You got to increase capacity for me. Instead of producing 100, you need to produce 300 per week, and I need you to be doing that next week. Well, if you've gone through these tests, then you'll know what to do. Third is, if you're running at a 5 Sigma, 6 Sigma level, you kind of wait for an error to occur. You're measuring, you wait for an error to occur, and you say, okay, I got it. Now, what caused that error? You go through the whole fishbone diagram that we discussed in the quality chapter, and you figure it out. And you say, okay, cool. Well, we had an error. We love it. It tells us that we're not perfect, and here's something that we can do to improve, make ourselves a little bit better. And then the fourth thing that I put in there is just know what's available. Know the available technology. Your constraint, better, faster, cheaper, that's relative to something. It's relative to what your competition is doing. So, if you're running along and you're doing just fine, but there's some technology out there that's going to run right past you and you don't know about it, then all of a sudden you may be making buggy whips in 1900 because you didn't anticipate what's going on with technological advances. So that's part of it too, is you can have a constraint that it's not your operation. Your operation's fine, but you need to be looking at what's out there. What do I need to be looking at to change? The example I give in my book is the hotel key. When years ago, the hotel key was a key. It was a key. You know, you'd go and you put it in the door and you'd open it up and it had a little thing on it that said room 107 with a hotel name on it. Well, how many of those room 107 keys wound up floating around that people didn't turn in? Probably quite a few. I stayed in hotels like that, lots, and I never had anybody come and visit me at midnight, but I certainly always made sure I had that little latch on the door. So that's old technology. New technology, it looks, what's the key? It looks like a credit card. They make them special. Each one's got its own unique algorithm inside of it to open the door, and it's only used once. So, that's a technological advance that operation managers should be aware of. Where do you get that knowledge? Well, you get that knowledge by going to trade shows and keeping up on things that are happening. It's just part of the job, is keeping up. So, constraints, a couple of big examples of constraints. And these are, they're a little bit older now, but I think they're good examples. They both required U.S. presidential commissions to go and take a look at what happened. And it was the BP oil spill and the Challenger explosion. And Ronald Reagan had the Challenger explosion studied. And then Barack Obama did the same thing with the BP oil spill. And in both cases, the commissions came back, and this actually I think is pretty interesting, but they came back with a 9 or 10-step process that they went through in analyzing what happened. It's on page 106 of my book, but real quickly, first thing they said was, what are we studying here? Define the objective. Second thing is they built the team. They developed an implementation plan. Various individuals got pieces of that, analyzed the data, what went on. They probably did, Six Sigma type of fishbone diagrams at that point. Focused the analysis by defining the critical few questions to ask instead of looking everywhere. At some point you got to narrow it down and say, okay, what's our hypothesis? What's a hypothesis? It's a statement made for thinking. So we've thought it through and we've got a hypothesis. We think this is the issue. Now we're going to go forward and we're going to work on that. They run additional tests where required. Number 5. Number 6, to define the analysis and look at other possible causes. 7, they reach a conclusion, and 8, they recommend a course of action. Both of these commissions did the exact same thing in their reports that they presented to the President of the United States. It's good enough for them. I think it's good enough for us. They did a good job of it. So theory of constraints, lots of stuff in that. There's some math in there too. I'm not going to try to go through that in the video, but read that chapter.